All right, thanks everyone for coming. So my name is Brian Duff, and I'm a software engineer on the Android team at Google. And I lead a team called the Context team. We actually manage a couple of APIs. So one of them is Nearby, and the other one is an API called Awareness. But today I'm going to talk a little bit about Nearby specifically. Nearby is an API for proximity. So it's kind of relevant a little bit to this conference in the context of IoT. I'm going to talk a bit about how you can use Nearby to add proximity features to your apps. There's a bunch of different APIs that we have. So there's Nearby Messages, which is a sort of pub/sub API for devices nearby. There's Nearby Notifications, which is a feature for showing notifications based on nearby beacons. And Nearby Connections, which is a peer-to-peer offline API. And I'll go through each of these and sort of give some code examples and talk a little bit about what you would use each of them for. So I wanted to start off just by giving a little bit of background about how Nearby got started and sort of what some of the ideas behind it were. We started with a really basic idea, which is that we think our phones and other devices could work so much better if they could really easily detect when they're near each other and could interact really seamlessly. We actually started off as part of the social effort in Google, so part of Google+. And our sort of original idea was like, can we use this technology? Can we use some technology to help you to connect to people who you don't know already? So like the idea was like make it really easy to add people to your circles and stuff like that. These kinds of activities like connecting with people and sharing with people are really easy in the real world between people. But when it comes to your phone, it can be kind of clunky. You know, like it involves exchanging telephone numbers or QR codes or something kind of ugly like that. So we want to make it possible to just walk up to something and start using it just by being close to it. So if we're going to do that kind of stuff, like what technologies can we use to do that? The really obvious one is Bluetooth. So Bluetooth is a 2.4 gigahertz radio technology. It has some interesting properties. It travels through walls. It has a range of about 100 feet. So with Bluetooth, we have a couple of options. When we started the project, Bluetooth Classic was probably the most ubiquitous technology we could use on all Android devices. So there's sort of a hacky thing you can do there where you change the Bluetooth name of the device and you start advertising, and that way you sort of like are transmitting some information that other devices can find when they scan. Newer technologies like Bluetooth Low Energy make this easier, so there's a sort of advertising packet where you can encode a bunch of data and you can scan for that in a fairly low power way. So this is one technology you can use to sort of transfer small amounts of data between devices in an energy efficient way. But one of the things we really wanted to do was to say with like certainty, these two devices are in the same room as each other, like they're really close to each other. And there are limitations on how well you can do that with Bluetooth. Martin from the Bluetooth SIG gave a really good talk yesterday about Bluetooth, and one of the things he talked about there was using the signal strength, the RSSI, to sort of approximate the distance between devices. But this is a somewhat inaccurate approach. There's a problem with the radio signals where they can sort of bounce off walls or go through the big bags of water that we all are, and this causes a problem called multipath, where basically when you see a signal, it kind of traveled through different objects or bounced off objects before it got to you. So the signal strength is not necessarily an accurate indicator of distance. So we'd really like to be able to say for sure you're in the same room as some other device. So we thought about audio. Audio is actually kind of an obvious technology to use. If you think about like speaking in a room, the people inside the room can hear you, but if you're outside the room, unless you shout really loud, like people generally can't. So we thought, like, let's try and build a technology that uses audio to detect when devices are near each other. Our initial prototypes of this were really, really irritating. We really kind of pissed off all the other teams that were sitting near us by like having our phones like constantly transmitting this like really ugly, screechy noise. So we knew that we knew that it would work in some way, but we knew it wasn't launchable in that state. So we worked closely with a team in Google Research to come up with what's essentially like a glorified audio modem, and we had them work with us to sort of shift the frequency range of our sound up to around about 20 kilohertz. At this range, most people can't hear this sound. It also has the added benefit that because of the high frequency, it's harder for it to go through walls. And it actually works pretty well as a way for telling that devices are in the same room as each other. I have a video which I have no idea is going to work, so let's see how the Wi-Fi is. because you can't, there we go. Because you can't hear this sound, this is kind of what it looks like if you run it through a spectrum analyzer. As I say, most people can't hear this. We had a couple of interns on our team who were like super crazily young, and they could actually just vaguely hear the sound, and they were really useful because we could have them help us to debug things. But this is what it looks like. It uses a technology, like an approach called direct sequence spread spectrum, and this makes it kind of like, it's a pretty low bandwidth channel, so we can only, again, transmit a very small number of bytes across this, but it's extremely resilient. So even if there's a lot of noise interference in the background or the signal like bounces off lots of surfaces, we can still pick this up and decode it with a fair amount of accuracy. So after we got this working the first time, as is sort of typical with Google, we got this working on a couple of Nexus devices, and it kind of looked good. But we weren't sure if this would work on all Android devices because you think about it, like phones are not really designed to handle audio at this range because humans can't hear it. So myself and a bunch of folks in our team, I remember sort of like running around the Google campus with like big stacks of like different devices and just trying this out in lots of different locations, like conference rooms and cafes and outside spaces and noisy places and quiet places. And it turned out it actually works pretty well. We get pretty good accuracy across almost all Android devices with this. So, I mentioned that, let me find my mouse again. I lost the, oops, sorry. So I mentioned that we have a fairly low amount of bandwidth with this. For most applications, you probably want to send some larger amount of data between the devices. So, we ended up building this incredibly fancy, complex thing that we call the CoPresidents Server, which is really fundamentally just a massive hash map in the cloud. And so the way that this works is like when your device wants to send some information to other devices, it associates a token with that content. It sends the token and the content up to the cloud. We store it for some short period of time. Other devices nearby then subscribe and they listen over the microphone or over other radio technologies. And when they hear the token, they send the token up to the cloud. And the token acts as a key, essentially. If you're close enough to hear that token, then you can get the content from the server. When we built this, we, of course, assumed that Nearby was going to be massively successful. So we took all the space that we could for the token and made it long enough that guessing it would be really hard, and the probability of it colliding with other tokens is really low. But it's still relatively short. It's short enough to fit in the radio packet. So we had a lot of fun building this technology, but up to this point, it really was just like a kind of an experiment fundamentally. And we, at this point, we'd left Google Plus and we'd moved to the Android team, and we'd sort of given up on this idea of broadcasting your Google identity to other devices nearby, because it turns out people found that kind of creepy, surprisingly. So we thought about what can we do instead that involves devices, and we were really looking for use cases where this kind of magical thing of you just walk up to it, you're near it, and it just works. And so Chromecast is a device that Google has which sort of allows you to cast multimedia content to your television. And it has this sort of problem where you have to be on the same Wi-Fi network basically to cast things. So imagine you go to your friend's house and you want to cast something. You've got this awkward interchange of getting the Wi-Fi password for the router, which may be some long hexadecimal number that you're typing into your cell phone. And of course, this is it's a feasible thing to do, but it's kind of a painful experience. And we think we can probably make that experience. We thought we could make that experience easier. So we built this feature called Chromecast Gas Mode. And it turns out that televisions are pretty good at generating ultrasound as well. So we do this thing where we use Wi-Fi scans on the Chromecast device and on the phone to sort of get an initial approximation of whether the two devices are near each other. And then we turn on ultrasound on your television, and we light up the cast icon on your phone. And when you click that, then we turn on the microphone and we listen for the token. And if we hear that token, we just let you cast, regardless of which Wi-Fi network you're on. There's also a fallback to a PIN code, which is still better than the Wi-Fi thing. Okay, so since we got a use case and we got a technology, the most impactful thing we felt we could do at that point was to take this stuff and turn it into an API and then ask like all of you guys to find really cool use cases you could build with this technology. This is actually one of the really powerful things about building APIs is that the impact of what you build goes far beyond just the API itself. It's sort of multiplicative, and people sort of build cool things with your APIs. So we built the Nearby Messages API, which sort of takes all this signal processing and all the sort of radio stuff that we do underneath and provides developers with a really simple API to do this. We also built this for Android, of course, and we built it for iOS as well, because when we say we want you to walk up to any device and just make it work, we mean every device, and that includes iOS. So we make sure, like, at every stage that the iOS API has complete compatibility with the Android one. And so we were really excited to see, like, a bunch of app developers built some really cool things with Nearby Messages, sort of apps which allow you to share things with people nearby, apps that allow you to find things that are near you. Games is also, like, a really popular thing that people use Nearby Messages for. So this is sort of like connecting to players who are around you and sort of starting games with them. Okay, so I assume many of us are engineers, so like I wanted to sort of dive into some code and give some examples of what this looks like in your app. It's really simple. Like there's like one line of code that's like as simple as it could possibly be. I actually I kind of cheated a little bit here because there's like probably, I don't know, 50 lines of boilerplate code you have to do before this to set up the Google API client. So if any of you ever used Google Play Services, you're probably familiar with that. It's kind of a standard thing. But once you get that sort of initial setup stuff done, this is what the API looks like. You can publish a message, and you can send up to around about 100 kilobytes of data this way. You can code it. And by the way, that size limitation is mainly just so that we don't Nearby Messages doesn't become like a general Google Cloud storage system, so we have to have some kind of like arbitrary limit to the amount of data you can store. You can encode this data any way you like, and by default this uses like every radio technology and audio technology that we possibly can to get it to any other device that's nearby. But there's some options you can pass here to do things like limit it to devices within earshot, and that would use the ultrasound mechanism only. And here's the other side of this. So this is how you subscribe and how you get the message. Really simple callback interface. There's an onFound method where you get the message, and you just call subscribe. And again, there are some options you can pass in here, but this is sort of the gist of the API. So having done that, we moved on to thinking about like what other things can we use this API for. And again, if you went to Martin's talk on Bluetooth yesterday, you know that beacons are kind of a popular technology recently. So beacons are sort of they're these kind of like coin-shaped devices often that are battery powered, and they sort of emit a radio signal using Bluetooth Low Energy, and they can kind of just be on all the time. And you can sort of attach content to those beacons. You can either encode it in the advertising signal itself, which is a relatively small payload, or you can just transmit some UUID and associate that with a larger amount of data in the cloud. And Google actually has this entire like beacon platform built around these things where there's a sort of a standard for the transmission format called Eddystone, and Google has a cloud service where you can associate content with Eddystone beacons. So Nearby Messages, we actually made it into sort of the recommended API for scanning for beacons on Android. You have a bunch of choices around this. There's a low-level Bluetooth adapter API in Android that this is a thing that Martin demonstrated yesterday. There's a bunch of things that we add on top of that sort of make Nearby Messages a sort of slightly higher level, more compelling option than that. So just to talk through some of those things, like the first thing is really permissions. The Bluetooth adapter APIs on older versions, I think it's like Lollipop and before, they require your app to have the Bluetooth admin permission, which is a kind of a ridiculous permission for you to have in order to just scan for Bluetooth, because it's the permission that lets you do things like start advertising and stuff like that over Bluetooth. Android changed so that you don't require that after Lollipop, but we made this API basically not require that for any version of Android. And we also, we give you free stuff. We give you free scans. If you want to listen for beacons all the time, you could just like have your app run a background service, at least until all, and just like scan all the time. However, that is not very power efficient, so you probably want to time slice it in some way. But it turns out actually different parts of Android are doing scans all the time. Location, for example, on your phone does Bluetooth scans periodically. And with the Nearby Messages API, what we do is we sort of consolidate all these scans together. And if you have if you're scanning for, if you're subscribe to a particular type of beacon, and something like location does a scan, will forward the result to your app. And then finally, talking about the background stuff, you might have noticed that there's a big focus on battery, especially in O and onwards. Android's kind of becoming more restrictive about what apps are allowed to do in the background. And so one of the features that we have in Nearby Messages for beacon scanning is that you can register a subscriber with us, and then your app can go away. It can go into the background or it can die. And we'll wake your app back up. We'll start your app back up again when we see a beacon that matches your criteria. So as Android becomes more restrictive around background stuff, this becomes we have to provide more hooks to wake apps up when relevant things happen, and we manage the power of that sort of inside the implementation. So here's an example of how you subscribe. This is kind of similar to the last example, a couple of extra things, but the API is roughly the same, so Nearby Messages subscribe. The main differences here are I'm sort of saying here BLE only, and this is how I tell it to, don't turn on the microphone, don't start scanning for Bluetooth Classic, just do BLE scans. The other thing you'll notice that's different here is that what we're passing in is, instead of the message listener that we had the last time, we're passing a pending intent. And so this is sort of the hint that this is a background operation, and this is the handle that we use to wake your app back up again once we find the beacon. And this is the other side. So when you receive this intent, there's this sort of wrapper function that we provide where you can pass in a message listener, and you sort of implement this on-found callback, and you can sort of get the content from the beacon. The content you get here, by the way, is the payload that you associated with the beacon using the beacon tools or on the beacon dashboard. So it's not the raw sort of beacon data. It's the chunk of bytes that you associated with the beacon in the dashboard, and you basically get beacon attachments that are associated with your app. So far, the scanning that we've done is just for things associated with your app. There's also a sort of more complex part of the API, message filter, which lets you get public messages. So by default, messages are app associated, but some messages attachments to beacons can be public. You can scan for them by using the message filter API. There's also, if you're not bought into Google's like beacon infrastructure and you want to just get the raw beacon information and like look it up on your own server, you can use message filter to scan for raw BLE advertisements. And there's some special callbacks we also provide. So the RSSI signal changing over time is something that some apps are interested in order to sort of provide thresholding. But there's also, we do this thing where we try to the best of our ability to estimate the distance of the beacon to your device. And as I say, this is not entirely accurate, but we have a model of like calibration for many Android devices, so we're able to do this as accurately as we possibly can and give you sort of an abstraction of what that distance is, so you can sort of see how far away the beacon is. So just to be like totally inclusive, here's an example where we're scanning for iBeacons. So iBeacons are Apple's beacon format. So really just the one simple change here is just to say include iBeacon IDs. And when we get the callback, the message that we get here is not a beacon attachment, but it's actually a thing that represents the beacon itself, and we can convert it to an iBeacon ID from which we can get information about the beacon, such as the UUID. Okay, so all of these things that I've talked about so far, they have a pretty major limitation, and that limitation is your app has to be installed, and it's a pretty obvious limitation. But when it comes to like interacting with things around you, it would be nice if there was a way for people to know that your app is relevant for things that you're near. So we announced this program at Google I/O last year, and this is Nearby Notifications, and the sort of general idea here is, so think of an example where you're maybe at the local coffee shop and there's a long line sort of waiting to order coffee, and you could skip this line if you had the Star Peats app on your phone, but only if you knew that was possible. Or another example is that the thing that Martin talked about yesterday with you're in a museum and you want to get information about an exhibit that you're standing next to, and the best possible experience you can have for that is to have the museum's app. But you might not know that you can do that. And so how do we sort of tell you about that? So Nearby Notifications, the Nearby Notifications program allows you to sort of attach applications and sites to beacons. And then if we can determine that the application or the site is really relevant to the user in the context that they're in, we'll show a notification on their phone even if your app is not installed. And this notification allows users to jump into the app or to the site at an appropriate location. So it's kind of like deep linking, essentially, that's triggered by beacons or proximity. One of the things we found this really useful for internally was to set up, Google has a bunch of hardware products and more coming, I guess, and setting them up can sometimes be painful. You have to also install an app a lot of the time. So we actually added a bunch of default nearby notifications that allow you to set up new devices. So this screenshot's an example for if you just unboxed a Chromecast device, you'll see this notification on your lock screen, and you can just click on this and install the Cast app and set up the device. The way you set these notifications up is, so the beacon dashboard that I mentioned earlier, there's a big chunk of essentially JSON that you can attach to the beacons. It's a special payload for those beacons, and it sort of explains what the title of the notification is that you want to show, the destination of the beacon, which can either be an HTTPS URL or an intent into your app. And when users click on the notification, if your app's not installed, we'll send them to the Play Store. After they install the app, there'll be a continue button in Play Store that they can click, and it will take them back to that intent again, so directly into the place in the app where you want to send them to. You also have some control in this JSON attachment over targeting, so you can specify things like your notification only shows at certain times of the day, or it only shows when the app is not installed, or a bunch of things like that. One thing about this feature is that it's kind of a nice benefit for app developers. Potentially, you get sort of free advertising, I guess, on approximately 1.5 billion devices. It's sort of a big boost. However, we have to take the experience of users really seriously on Android, and we don't want to show lots of kind of spammy notifications all the time in the platform. And so because of this, we have a bunch of criteria that we use to determine whether a notification is high value. The most obvious is that the attachments have to be really contextual, so they should be related to something that the user is near in the real world. And the way we sort of measure that is just how often people interact with them, like how often do people click on them. The other thing is that we want to make sure these notifications provide a good user experience. They should jump into the thing that the experience you're trying to provide. So, it's not a good user experience if users click on it and they go into your app and then they have to sign up for an account, and then there's like 5 pages of like sign up screen, and then it goes to the thing. Ideally, you should jump straight to the thing that the user that's related to the thing that's nearby. And then the other thing is really targeting. Like, be very careful about where you position the beacon. Make sure that it's visible to people for whom it's relevant, and be strategic about where you place beacons. So that we had one pilot where a particular retailer was using extremely high-power beacons inside a store to try to get people from outside the store to come into the store. And even though that sounds like a really appealing thing for the owners of that store, it's not a really appealing thing for all the people in the mall that are kind of walking past the store and don't really have any interest in it. So this is an example of what we'd consider a bad notification. So yeah, definitely try to target those things appropriately. So here's an example of an attachment. As I say, it's a fairly simple JSON format. There's an intent. There's this particular one says, like, only show this notification when the app's not installed between 9 in the morning and 5 p.m. So I wanted to talk really briefly also about nearby connections. I'm not going to go into a lot of detail about connections. It's a little different from the rest of the APIs. It allows devices to connect to each other without an internet connection, which is something that is quite useful. It's currently implemented using MDNS, so it does require a local network connection, but it doesn't require an internet connectivity. The discovery protocol here is similar to the thing that Chromecast uses. It uses MDNS. The devices need to be in the same network. It's often used by games for things like second screen experiences. The main reason I'm mentioning it today is because one of the most common things that we've heard from developers is that they want a proximity API that works offline. Nearby connections is really the foundation of that. And we're going to be talking about nearby connections, some major improvements to nearby connections at Google I/O this year. There's a session called Enabling Contextual App Experiences. So I'm going to be really excited to talk about that more in May. And if you can tune into that, there's going to be some interesting stuff. Just to sort of wrap up, we really need your help. So building APIs, the more feedback we get, the better the APIs can be. And we realize that like we've got part of what people need right now, but we know there's more things that we can add. So like think about use cases you can build with this technology. Let us know, your experiences with the API when you use it, what things you'd like to see work better, what things don't work so well. And get in touch with us. Our team's really open to feedback. You can sort of reach out to us. We monitor Stack Overflow fairly regularly, so if you have technical questions, that's a good place to post those. You can contact us directly at nearbyteam@google.com. We can't guarantee that we'll reply to every message, but we'll do our best. Really, that's a good place to send feedback about the API or things that you'd like us to build in the future. And you feel free to follow me on Twitter. And this is our documentation link. I realize I covered everything in a fairly quick and summarized way, but this goes into a lot of depth about how you set things up, and there's lots of detail there. So thank you all, and I guess we probably have some time for questions. Okay.